Okay, in the last video, we were learning how to add or subtract when the denominators were the same or when we had like bases. In this video, we're going to learn when we have unlike bases. And so in this case, the denominators do not match. Anytime you add or subtract fractions, the denominators have to match. And so in order to do that, we need to find something that they have in common or some way to get them matched. Worst case, if you can never find a match or something to get it to match, you simply just multiply it times each other. So you would multiply the left side by the right denominator and the right side by the left denominator if you have to. In this case, if we simply multiply the bottom right by 5. So if we take this guy and we multiply by 5, if I distribute that, that's going to become 5k minus 10. And now they match. But if I do it to the denominator, I also have to do it to the numerator. So in this case, I need to also multiply this. That way the fraction stays balanced, okay? So up top, we'll have 5 times 4, which is 20. And so if I rewrite this, we have the top as k squared plus 16 all over 5k minus 10 minus 20 over 5k minus 10. Now that the denominators match, we can simply subtract up top. And so again, when you're adding or subtracting, you have to only combine like terms. And so in this example, we have k squared plus 16, but then minus 20. So that leaves me with a negative 4. Okay, we had a positive 16 minus 20. Okay, from there, we can try to factor now or take out greatest common factors because we've now done the subtraction process. Okay, this is also where you might want to look for the restrictions now, though, before you do anything else. And so if we set that denominator equal to 0, then we would find out that we have to add 10 and then divide by 5. And so k cannot equal 2 because if k equaled 2, then we would have a 0 in the denominator, okay? On the top, we have a difference of squares. So we're going to end up with k minus 2 and k plus 2. Because there's no middle term, we know that it's always going to be opposite. And then this is a perfect square. So the square root of 4 is 2. Okay. And so on the bottom, if I pull out a 5, right? And that's kind of silly because I know I just multiplied it over here to get a common base. But if I kind of put it back, right, I get this, and then now I can simplify my answer better. And so these are going to cancel. And so your final answer will be k plus 2 divided by 5. And the restriction here is k cannot be 2. And we found that before we canceled things out. Okay. Let's try one more. That way we can see another one that needs a common base. Okay. So I believe on the notes, this is number 10. So we have 7y plus 8 plus 35. And we have y squared plus 11y plus 24. Now, anytime one of the denominators is a quadratic and the other one's not, and it's not matching, most likely you want to factor this first so that we can see if one of the factors matches, and then if we can find some common grounds there, okay? So let's go ahead and factor this denominator, the yellow denominator. So if we do the AC method, we have A times C is 24. And so we want two numbers that multiply together to give me 24, but when I add them, they're going to give me that 11. And so that is 8 times 3. So 8 times 3 gives me 24, but 8 plus 3 gives me this 11. And so we were able to change this denominator to y plus 8 and y plus 3. Now, if you look at the two denominators, okay, it looks a little better, right? The only thing that's different now is that the left fraction is missing that y plus 3. And so now we have a common piece that we can help the denominator with. And so we're going to multiply the top and the bottom by that missing piece, that y plus 3. Because then the denominator will be y plus 8, y plus 3. Up top, you can leave it for now, if you want, separately, because it'll be 7 times the y plus 3, okay, plus 35, okay? And so if you distribute this 7, you're going to get 7y plus 21 plus 35. Now you can combine like terms. So in this case, your like terms are only the constants. Your variable doesn't have anything else. So let's see if I have room. We're going to still have this 7y because that's the only variable on the top. And then you will have 21 plus the 35, which gives you a 56. And you still have this y plus 8, y plus 3. And then we want to try and refactor that after we've added it. And so if we take out a 7 again, we're going to end up with y plus 8 here, which is good because we have a y plus 8 in the bottom. Before you eliminate anything, make sure you set the bottom to equal to 0 to find the restrictions. So since the denominator can't equal 0, you want to set each factor equal to 0 to see what the restrictions would be. So in this case, y plus 8 equals 0. That means y cannot be negative 8, and y cannot be negative 3. So these are the restrictions. And then now you can cancel out what matches. So your final answer is 7 over y plus 3. That's a y. Okay. 7 divided by y plus 3 is your final answer. The restrictions are y cannot be negative 8, nor can it be negative 3. All right, so go ahead and practice some on your homework number 2. Good luck.